You guys did great. Hope you're happy. I'm happy. You ready? All right, let's do it. You ready? Get a pen and paper out. Let's do this right now. You're not handing it in, but I want to see the answer on everyone's paper. You've been at this job for a little while. You're now a manager at this company. Right? You're a manager now. You just got an increase in pay, you got promotion. You're telling everybody, I'm a manager now. Give it a year. You'll be going, God, I can't believe I'm a manager. God, why did I do this? Oh my God, these people that work for me, oh, they're hell. That's right, humans are hell. All right? The worst part of being a manager. You're being told, though, now that you're a manager for this department, it's a 24-hour company, you're scheduling the employees. And you're scheduling full-time employees all on 8-hour shifts. They can start any one of those 6 times, 8 a.m., noon, 4. You're looking at 4-hour shifts, but when you schedule an employee, they're working 2 shifts, 8 hours. You get it? There's overlapping. So when you're figuring this out, it doesn't matter how many employees you have unlimited employees, but however many you schedule, you have to have at least 5, whether they're coming on their second half of the 4-hour, or the second part of their 8-hour shift, or the first part of their 8-hour shift, 5 of them during that time. At least 6, at least 10, 7, 4, and 6. So what you're coming up with, how many are you scheduling to start at 8 a.m. at every one of these times, and you'll maybe even have more than what's required, at least that many, in order to fulfill that by scheduling, which is fine, but the goal is to have as few employees having to be scheduled during this week, or this particular day, as possible. Everybody hear that? And still meet those minimums. I'll say it again. Your goal and your bonus depends on it, because you're trying to keep costs low for your division that you're scheduling these employees for, is to schedule the least amount of employees possible, but still fulfill all these minimums for each one of these 4-hour shifts. Again, overlapping, the employee works 8 hours. Start scheduling. You have 5 minutes. I forgot, I got to set the timer. 5 minutes. And not only do I want to know how many you're scheduling each time, but have a total at the end of how many employees are going to be working. I want to know how many employees are going to be on that day that you're utilizing. If you got to 30 employees, I think that's too many. And you may have made a mistake.
What are the numbers next to the times? Like
That's the least amount that have to be working. You have to have at least 5. So let's say you had 3 scheduled at 4 a.m. They're still on shift at 8 a.m. and you need to schedule 2 more at 8 a.m. to have 5. Now those 3 are going to be finished, but the other 2 are continuing on to noon. But you need 6, so you need to schedule 4 more to meet that minimum. And those 2 now are going to be done, but those 4 carry on. You with me? See how it's done? Put a schedule together. There's no wrong here. I just want to see what you can come up with in 5 minutes. Now you're at 4 minutes. How many, okay, wow. How many, add up your total. Oh, you want 25? Okay, see if you can improve it. He is under 25. He's under 25 also, so see if you can improve it. Casey, how many are you at? 20. 20? Wow. Wow. Anybody else? Hey, give me a number. Okay, how many? 19. 19. 19. How many? Come on, I want to hear a 25. Sean, you're going to give me a 30?
No, I'm going to, no.
Oh, darn. 22, all right. Travis? You don't have a number yet? Good number. 19. Look at you. On first try? See, if you get that first try, was it only 1 try you got that? Anybody beat 19? Second try you got it down to 19. Anybody beat 19? Time's up.
I got it to 22.
22. First try? Because you keep looking at it, you can keep adjusting it, getting it down to a minimum number of employees. Now, here's, I'm sorry?
What's the lowest possible?
19.
Yeah, 19.
19, but you had to start at what time? That's where the luck came in. That if he did it on the very first try, he started at the right time, which was, you had to start at midnight. Did you start
I
at
started at 4 p.m. to 8 p.m.
That's where I started.
4 p.m. to 8 p.m.?
Yeah.
That's where I started.
You got 19?
Yeah.
Actually, we did.
But you had too many working here. There's no way you got 19.
I did
Dude,
five
hang on, you
people
guys.
there.
I wanna make sure you realize there's no way you can get to 19
But then
starting at 4 p.m.
You
So.
backtracked and said, I'm gonna take.
Oh, you went backwards?
I started at 4 and said, I'm gonna take 5 people at 4, and I'm gonna take
Wait,
5 from the previous
four what?
shift.
4 here?
4 PM,
You're saying you're adding 5 people.
5
To
people.
get to 10. You're assuming then 5 are coming down here.
Then I'm gonna go back, yes, then I backtracked and said.
But
I'll
how
go
did you
back
get to
there.
6 there? So
Then I-
whatever time you start, you always start with the number that you have to have scheduled. Because you know, wherever you start, you gotta at least have that many employees. So if you started here, there's no way to get to 19.
I started at noon.
I was gonna say, it's gotta be, I think you gotta start with the lowest number. I gotta make sure though.
I started at noon. and I
Let me
did
start
it
at midnight real quick. You ready? If I have 4 at midnight, they're carrying over to 4 a.m., but I gotta add 2, right? So then I got 2 more. The 4 are going home now, but the 2 are carried over to 8 a.m., but I gotta add 3, right? Everybody with me? Those 2 were going home. The 3 I just added are carrying over here, but now I gotta add 3 more. The 3 that started at 8 are going home, and the 3 that started at noon are carrying over, but I gotta add 7. And am I done? And then 7 carry over 0. And that's the only way I see to get to 19. You have to start with the smallest number. And I think that you thought you started with the biggest number, but I don't know how you got to it started with a 10. I think somehow you got a 4.
I started at the bottom one.
I can tell you how I did it.
Okay, wait, he said he started at noon and got to 19. 19 or 20? Okay, let's start at noon. Here we go. Help me out, Chris. 6, right?
Yeah.
They carry over. You gotta add. You jumping in? Okay. 4. Now 4 are carrying over. You gotta add 3. 3 are carrying over. You added 1. 1 carrying over. You added 5. 5. 8. What did we start at? I forgot. Noon. So we're up here. 5 carried over. So you're at 0.
Yeah.
And then we're right back at the beginning.
Well, then I just did my.
10, 13, 18, 19. So that got you to 19 also.
I didn't start with the full number. I didn't realize, like, I started at noon, and I thought, well, I didn't say I'm gonna put 6 people on, because I figured I would have people carrying over to the one before.
I don't know how you made that assumption, but that was one.
That's what I did.
I like it. Don't be wrong, but hopefully you would have recognized if you didn't have just the right amount carrying over from the previous time, that you assumed
I
that.
got super lucky apparently.
Yes.
I had no idea.
Now,
I did that.
this whole thing was to
Mine's
show
a
you
huge circle.
that
Mine is.
in real life, the company's going to expect you to do this in 5 minutes and come up with 19 every time. And so you've got to take this and look at it and say, what was the decisions? How many decisions had to be made to figure this out? How many decisions were involved that you didn't know the answer to? How many? I heard it. I thought I heard it. 6. You had to say to yourself, I got to schedule a certain amount of employees at 6 different times, and that's the decision that had to be made, right? Now you got to turn those decisions into equations. You recognize the decision that had to be made. You recognize the thought process you had to go through. Think about what you went through in the thought process. I'm going to start right here. To figure out how many would end up working from 8 to noon. How did you figure out? What did you do in your mind to say, this is how many? Real quick though, I almost forgot. We're going to use the variables x2, x3, 4, 5, 6. These are all x's. And these represent start times. 8 a.m. all the way to 4 a.m., all right? Think about the variables. What did you do in your mind to say how many will end up spending time working from 8 a.m. to noon? What did you do? Using the variables. What was there? The amount you scheduled, which is what letter represents the amount you scheduled? X1. And then what else determined how many would be working from that time?
The 5?
Say it again.
The 5?
No, no. This is the minimum you have to have there.
Right.
Determining how many ended up being scheduled. X1 is how many you scheduled at 8 a.m.
4-hour shift.
The 4-hour shift. But what are you doing in your head to figure out how many total will be working there? You have it. Spit it out.
You needed
2 numbers, 2 variables, but what's the other variable?
the other 4.
The other 4. What other
It's
4?
not carried on
X2.
from the 1-4.
Right, and what represents how many got scheduled?
X6.
There you go. Everybody hear that?
No, I'm so confused.
She said, in order to figure out how many your schedule are going to be working from that shift, You had to look at how many you're scheduling at that time, plus how many are going to be carried over that you scheduled in the previous 4 hours. Now you turn what you did in your mind into an equation. How many I'm scheduling at that time, plus how many I scheduled back at 4 a.m. has to be greater or equal to 5. You've got to take this real life situations and turn them into equations by figuring out what is it I was making decisions on, or what is it I have to make decisions on, and then what logical process do I go through if I were manually making this decision. Help me with the next one. How many ended up working from noon to 4 p.m.? X2 plus X1. You're getting it. You got it. You understand exactly where I'm going with this. I thought I'm going to race here. Wow. All right. You see where this is going? Now I hear more people telling me, whoops, that was X1. See, right now you're jump ahead of me. Be ready for the next one. I want the formula for everyone's schedule from 4 p.m. From 4 p.m. to 8 p.m.
X3 plus X2 equal to 10.
Is everybody getting this? All right, one more. What was that one? That was at 4 p.m. Give me 8 p.m. You got it. So now I think you guys got it. There's the variables. The number of employees you're scheduling at each start time. Here, whoa. We want you to see the objective function, darn it. And here are each one of the constraints. However many are scheduled at 8 a.m. plus however many were scheduled at 4 a.m. has to be greater than or equal to 5. The noon, however many scheduled at 8 a.m. plus however many you're scheduling at noon has to be greater than or equal to 6. You're taking into consideration the carryover from the previous 4-hour shift and how many you're adding in the 4-hour shift that this is for. That's exactly for all 6 shifts. There they are. You enter these into Excel. Let me get there. Look at this. I added whichever spreadsheet I opened, I had so many posted in, I don't know. There was 2 variables. I added these other 4 variables. There was only 4 constraints here. I added 2 constraints. And I started putting in the numbers. Here we go. There's 1x1 plus 1x6. So there's my x1, there's my x6, greater than or equal to 5. There's 1x2, 1x1. 1x1, 1x2, greater than or equal to 6. Everybody see how I did this? The objective function. I said to you, your goal is to have what?
Least amount of workers.
The least amount of workers. Minimize or max? Minimize, exactly. I don't even need to write it down. Here we go. Where is it? It is minimize. When you add all the variables, that's exactly how many employees you're scheduling, which the least amount we came up with is 19. And it's just adding each one of the variables together, because that's exactly how many you're going to schedule for that 24-hour shift, 19 employees. We'll plug it in. Now, talk me through this. Here, I just want to show you the formulas. I have 6 variables. I put zeros all the way across where I want the optimal solution to show up. And remember, sometimes there's more than one optimal solution, but there's only one objective function value that's best. There can be a different combination of answers, but the best we're going to be able to get is 19, even with the different kinds of schedules we have. And that's what you'll see here. The objective function. I'm taking every one of these times their corresponding objective function numbers and adding them together. These constraints, I'm taking every one of the numbers in the constraint times the corresponding optimal solutions and adding them together. Just like this. E6, da-da-da. You want this posted?
Yes,
Yes, please.
please.
Can't recall that. Most participation I've had this semester. All right, help me solve it. What do I click on first? Data. Very good. Then what? Solver. Now hang on, I'm turning off the screen. I don't want the variables in there. Hang on, I don't want you to see. I gotta get the variables out. I gotta get all the answers out of there so I can make it blank. Hang on. Come on. Look, I can't do this any faster here. Guess not. Darn it. One at a time. Won't even let me do more than one. Really? Hang on. No, it's a lot. Okay, hang on. Oh, I just hit the wrong stuff. What does this say? Found a problem. They won't even let me get rid of one of the constraints. Hang on. Oh, it put it up in the objective. What's going on here? Almost there. There you go. You haven't left the movie theater, have you?
Isn't there a button on the right-hand side that says clear all?
I got it. Okay, here we go. You ready? This opens up all blanks, supposedly. Tell me what goes in set objective. I bet nobody did this wrong.
$E, $E.
Thank you, Sean. Look at that. $E, where's that?
18.
18. Thank you. Okay, is this a max or a min? Right, min. Changing what? Give me in words, not what cell locations, but give me in words what this is asking for. By changing variable cells. In words, what is that asking for? The cells that have what's going to be there? The optimal solution, where the optimal solutions are going to land. So the cell locations for the optimal solution, where all these zeros are, what is that? E16, help me out. $, E, $16, colon, and then $, all the way to what?
J.
J, $, is that 16?
16.
I don't know if you have to use $, on this, but there's a lot of things in your future you do have to.
If you click on the
$sign
cell-
just to get used to it, huh?
If you click on the cell, will it do the same thing?
Yeah, that's right. And we'll put the $, too.
It does? If you
Yeah.
click on it?
Okay, now, hang on, I gotta figure out a way to make this so we can see it. I wanna see the right-hand sides too. What do we gotta do here? There's no way it's gonna fit. That helps. All right, I don't know what, can I put these side by side? Is that even possible?
Yeah.
Oh, look at this. Hang on. You be wide enough? Okay. Darn it. Darn. Wait, what am I doing? Hang on. Yeah, I just wasn't leaving. Well, you guys are kidding. Because this is so darn. Okay, let's just go forward. Ready? Constraint. It's always, you say add constraint. You tell where the left side of the calculation for the constraint will be, which in this case is E22. Is it a less than equal, greater than equal? Greater than, go down to greater than equal. The right side is in cell right there. And then I hit OK. And there's that constraint. The rest of them happen to also be greater than equal.
Yes.
Since they're all the same equality, you can take a shortcut. Only if they're the same equality. They're all less than equal. However many in a row that are the same equality. The shortcut is add. Where is it? Add. The left side is going to be, is this the left side? All of these that are left, because they're all greater than equal. So E23 through E27 correspond with, I forgot, I got to go greater than equal. The right-hand side is going to be from the second one down all the way, is that 1, 2, 3, 4, 5, that's all of them? Yes. Then you hit OK. Now, all it did was put, instead of just one constraint at a time, it took those other 5 constraints and put them all together as one, because they were all greater than equal. And you can group just two less than equal, and another 2 that are greater than equal. It just saves time. What else do I got to do? Am I done? Can I just hit solve?
No, you gotta make
No, what? Hey, Trevor's on top of this. Go ahead.
the constraint variable non-negative.
That's right.
And then change the GR.
Very good. Thank you. Excellent. 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 Now, we're good? Been okay? How many employees is the least amount that we would have to use to fulfill that 24-hour schedule with those minimums?
19.
You see it right there. In this particular case, again, there could be an alternative solution, is 3 at, what was it, 8 a.m.? 3 is the next 4-hour shift. 7, is this the time where there's 10 of them at minimum? And they're carrying over, and there's probably 7 minimum here that worked out well. That's why it's 0, 4, and 2. But, Chris, give me your numbers here. I think they're different. Your 19 also, yours are different. Give me your numbers. What's that at 8 a.m.? 0, 6, 4, 3, 1, 5. And yet, it's 19. And fulfills all the minimums.
So is that the
you can
range
see
of
there's
optimality?
alternative solutions. Huh?
Would that be like the range of optimality then? Because it's the same thing, there's just a range of what could be? Is that?
No. the range of optimality is all about these numbers right here with the objective function.
Okay.
If these numbers were to change,
Is that a different optimal solution or something else?
I'm sorry,
Would that be considered like having a?
alternative optimal solutions was called, yes.
Oh, okay.
Alternative optimal solution. And a lot of these have alternative optimal solutions. But no matter which alternative optimal solution you go with, you should go with the first one you did. Why waste time? Once you have this, this doesn't change. No matter what the alternative optimal solutions are, this is the best it gets. The first time you get this number, that's the best it can get. Even though there may be more than one answer here on optimal, that does not change. All right, you ready? Here it goes. It's going to get. This is. I'm trying to start with what I feel is the easiest one on the PowerPoint. I see we're getting low on time, so we're just going to do the product mix. Are you ready? I think this is the easiest. And you just got done doing one with 6 variables. So you should be okay. Never had anything past 2 variables until now. We're going to get to these harder ones next week. Okay. Yes, finance major. We'll do a portfolio. Yes, supply chain. We're going to do a production one here. Yes, human resource managers or workforce assignment production managers. We're going to do. You have to assign the workforce. Whoops. What is there? You ready? But this one, you guys graduated, and you said before I go and commit to a full-time career where I'm going to hate my job after a year and I'm having to drive 35 minutes, wasted time in traffic to get to. You said, I'm going to take a year off and go to the Virgin Islands. I'm taking a year off after college to go to Virgin Islands. Anybody in on that? Or we're okay? Everyone okay? You saved enough money. It's not that expensive. You know, you've learned to live in a tent if you have to, right? Whatever the case may be. You know, you're a friendly person. You'll find a place to stay. Here's the deal. You see opportunity. You're a business grad from school of management. I don't know all your business on the computer, but still, you see opportunity that can't be lost, and you go ahead and buy a couple of boats. You got a loan with the guy who owns the bar you've been spending all your time at on the Virgin Islands. That's where I'd be year after graduation. Are you ready? And these couple of boats, you end up renting them out so often that you start to realize and calculate, what if I had more boats? And you got a couple more boats. Now you're at the point where you realize this is a full-blown business and a real opportunity because 2 more cruise ship lines have made their stop on the island in which you've been staying at. You're not even sure you're leaving this island. That's how great this is going for you. You with me? You've been working with 2 companies that you bought these boats from, 2 manufacturers. And you said, I have got approved for a loan. How much? $420,000. Part of it has to be your own money. You've been saving because you've got to do 10% down, but they're going to lend you the other 90%. That's real business there, by the way. Okay? So you got about $42,000. You're getting a loan for blah, blah, blah. Help me out here. Whatever. Right? The other 90%. Here's the deal. You're about to expand this business, and you're going to buy a bunch of boats from 2 manufacturers. Now, I used to run this computer company, and I worked with some manufacturers, Intel, AMD as an example. And the relationship you have with manufacturers is a big deal because the benefits of having these relationships with these manufacturers are huge. There's times where I can put commercials, have commercials made, and as long as I put Intel's little emblem and ding ding at the end of it, they would pay for more than half of that commercial. That's the kind of relationships that you can benefit from. Certain times of the year they offer you these specials, these kind of things. Another time they said, hey, how about 2 of your manufacturing employees, they put all the computer equipment together and servers and everything, come to our conference. We'll pay for them. They pay for the employees' hotel, they pay for the airfare, all their food, for the whole conference to learn about Intel products and the advantages of having Intel products in our equipment that we were manufacturing, and so on. So this person, you realize that this relationship's important because these manufacturers have been providing you with certain things, and they said, if you do this with us, we're going to provide you with a bunch more, including advertising help, which is a big deal. Help pay for the ads. It's doing so, you decide to keep goodwill that however many boats you buy, here it is, however many boats you buy, you're committed to have half of them bought from one manufacturer, half of them from another. You with me? What did I just describe to you? An objective function or constraint?
Constraint.
It's a limitation. No matter which boat you decide to buy, and you're going, wow, this boat's such a good deal, you've already committed to half of the boats are going to be from one manufacturer, and the other half to keep those relationships strong. All right? Even though you may have to spend a teeny bit extra money because there's a better deal, maybe. And don't forget, you're always going to negotiate after you get done with this class, right? Your company's called Floataway Tours, and you realize, however your money's going to be spent, you want to buy at least 50 additional boats. Now, this is a real business expansion. You're going to buy 50 boats at least. Objective function or constraint?
Constraint.
So limitation, less than equal, greater than equal.
Great.
Almost. Not at most 50 boats. You got to buy, your objective is to buy at least 50 boats. You're going to buy 50 boats or more. Matter of fact, this 420,000, you want to stretch it out to as many boats as you can. Each boat represents profit. You ready? One more thing. Let's see. The two of you wish to have a total. You also realize that some boats get rented out by some families, some boats get rented out by couples, and you want the seating capacity for each boat will be listed of your choices of boats to buy. It's all coming to where you're telling me which boats you're buying and how many of each one. And when it comes up, it's going to have the seating capacity, and the seating capacity helps determine the profit, because the more seats, the more profit, obviously. But the more seats, the more expensive you got to pay. You want, out of however many boats you're buying, which we know is going to be 50 or more, you want the total seating capacity to be at least 200 seats out of those boats. Less than equal, greater than equal. Thank you. Greater than equal. Because you add up all the seating capacities from whatever you're buying, they're going to be 200 or more. You with me? Here's your list. This is it. This is your only choice. It's 4 boats. Here are the manufacturers. You want to buy as many from this company as you do from this company. These are your relationships. They're going to help you. Here is your cost for each boat. You have 420,000. This one's only $5,000, but it's a 2-seater. Fun. Couples love it. All right, but families love this one. Right? But look how much more you got to pay for it. Here, you did all the calculating, and this is the daily profit from that boat if you decide to choose to buy it. My question for you is, you got to make this decision. How many variables of the decisions you have to make? Don't look on the slides either. It happens to be 4 because there's only 4 boats. It's all about how many of that, how many of that, how many of those, and how many of those. How many of each one is the decision. And there's only 4 choices. So I'm going X1 through X4, okay? Here we go. X1, what are they? Speed? Is it? I'm just going to go Speed Hawk. Speed H, there we go. X2 is the Silver Bird. X3 is going to be our Catman. And X4 is our Classy, okay? All right? Here's our variables. Let's start with this phrase. You ready? Hey, manufacturers, I appreciate you guys, females, males, just you people, your company so much that I'm going to buy the same amount of boats from each of you. Put that in an equation. 2 manufacturers. What variables represent the boats you're buying from one manufacturer? Say it again. X1 and what?
X2.
X1 and X2 is one manufacturer. And what variables represent the other manufacturer?
X3 and X4.
And you're buying the same amount from each of them. X1 plus X2 equals X3 plus X4, which guarantees we're buying the same amount of boats from each manufacturer. This will not enter into Excel. It won't enter into software. You've got to use algebra to have all variables on one side and nothing but number on the other side, which would be the right-hand side of a constraint. So I'm going to subtract X3 and X4 from each side to get it over to the left, but what will I have left on the right after I get rid of X3 and X4? There's nothing left. 0. So now you got X1 plus X2 minus X3 minus X4 equals 0. This is not even a less than, greater than, or a less than equal, greater than equal. This is one of the few equals. This is the first equal we've seen in this class, I think, because we made that commitment. So we're obviously got to buy an even number of votes because of this, right? Either we'll have a little bit of money left over, or we're going to go over budget, which is impossible. Let's talk about our 420,000. Is that a less than equal, greater than equal $420,000?
Less than equals.
Because it's the most we can spend. With our 42,000 plus the loan, that's our total budget. Less than equal 420,000. Now you remember from previous lectures that if the right-hand side's in money, dollars in this case, if it's in money, the left-hand side's got to be in money. But these variables are how many of each vote. Convert it to money for me. X1. That's right. You got to multiply it times 6,000. However many X1s times 6,000 apiece is how much you're spending. Plus you're going to buy X2s at $7,000. Plus you're going to buy, what is that next one? $5,000 for each X3 plus $9,000 for each X4. Right? Go ahead.
Why are we subtracting those?
Why? Oh, no, you're adding them. They represent how much you're spending total. If you subtract them, you're never going to get to 420.
So what is that top?
Okay, let's pretend you bought 2 speed hawks.
Right.
How much did you spend, Sean?
12,000.
That's right. Now you bought 2 silver, whatever, widows.
14,000.
Another 14,000. If you subtract 14 from 12, you're going to add them.
I'm just wondering why that would top equal that bottom one down there. We used did that.
Ah.
What does that have to do with?
The only reason we're subtracting is because 2 variables are on the right side. This is how many we're buying from one manufacturer, X1 and X2. This is how many from the other manufacturer, and we told them we're buying the same amount. We had to subtract these to get them, use algebra to get them to the left side.
Right.
That's why we have subtraction there. Usually, you very rarely even have subtraction on the left side. I mean, we didn't write it with subtraction.
Right.
It became subtraction because we had to get it from the left side to the, or from the right side to the left.
But like, does that just sit there now and we're moving on to something separate?
No. When we enter this into the software, yeah, we're on something separate. This has to do how many we're buying from each manufacturer. This has to do with how much money we're spending. Yeah, each one's a different subject. Is that what you were?
Yeah,
I'm sorry.
trying to correlate what they were, why they were.
This one's how many we're buying from each manufacturer. This one's how much we're spending with however many we're buying in each one. The next constraint's going to be, we want to buy how many votes at least.
Seating.
What was it?
Or seating.
In the seating we got to get to also. But how many votes? At least 50. So that's less than? Greater than equal to 50, right? And 50 is the number of votes. Each variable is the number of votes. So again, the left side would be just x1 plus x2 plus x3 plus x4. It is greater than equal to 50 because we got to buy at least 50 votes. And the variables represent how many votes we're buying of each kind. I'm not writing it clearly because it's right here. Oh, I don't want to jump to the objective function. Here it is. We want to buy at least 50 votes. We want to spend no more than 420,000. We want to make sure we buy the same amount of votes from one manufacturer that we do the other manufacturer, but then we apply algebra. I want to point something out. Where you have variables on the right side, this is heavy in Chapter 6 happening. And you've got to make sure you realize you've got to use algebra. Chapter 6 is all about getting these variables to the left side before you enter them into the software or the Excel. Okay? So that's why we subtracted them and we got a 0. If there's nothing left, it's 0. We're going to have a number on the right side. Now, the other one was the seating capacity, greater than equal to or less than equal to 200, right? Was it 200? Do we want at least or at most 200 seats?
At least.
At least, greater than equal to 200. But the variables are how many votes. Let me go back to the chart. I got to turn the variables of how many votes of each kind we're buying into its seating capacity. So I take x1 times what?
3.
3 times x1. Because however many, if we buy one of these votes, it's providing 3 seats. We buy 2 of them, it's providing 6 seats. Plus x2 its seating capacity, 5x2, plus x3, 2x3, plus 6x4. It's not neat. It's greater than equal to 200 because it's right here on your PowerPoint. Let me get to it. There it is. 3, 5, 2, and 6 is the seating capacity for each vote. However many we buy, they got to add up to more than 200,000. Is that it? Objective function. What do you think we're trying to do here? You know, hang on, look at all the information you've got. Is there? Exactly. Everybody hear them? Maximize profit, because that's the information we have. You know, we're not trying to minimize costs. If it's set up there, whatever boats you have, let's spend the least amount of money possible. No, it said we have 420,000, and just don't go over that. It's not about spending the least amount possible, because we have to make sure we're getting at least 50 boats. We got to make sure we have seating capacity 200. What we're trying to do is we want a combination of boats that make sure it gives us 50 or more, that make sure it have 200 seats, and maximizes our bottom line. That's what it's all about right there. And so the objective function is the max, all the variables multiplied by the amount of profit they're going to provide, because we did the math on this. We've already have 4 boats. We know exactly how this business works, and we're able to calculate the profit on it. You ready? Now this, from now on, you're looking at output, and you're answering the questions. This is on your next quiz. How many boats are you buying of the Speedhawk? Hang on, I gotta get the output. Wait, what is that? Oh, okay, just checking. How many Speedhawks are you buying? Come on. How many? How many Speedhawks are you buying? Really? Now look. 28. What represents the number of Speedhawks you're buying? What represents it in our formulas? Huh? No, say it again. I heard you. I missed it.
Value?
Not the value is the optimal solution, but what represents how many Speedhawks? What variable represents
X1.
X1. So you should go right to X1, find its optimal solution. And here's the deal. It's not going to say on your question for this next quiz, it's not going to say how many X1s are you going to buy. It's going to say how many Speedhawks are you going to purchase. You got to realize Speedhawk, oh, we used X1. So that's representing the number of Speedhawks. You jump to the output, you look at X1, this is how many Speedhawks. How many silver, whatever you're going to buy?
0.
How many catamarans, whatever,
Zero.
boats you're going to buy?
0.
0, and then how many classies?
28.
Are you buying at least 50 boats?
Yes.
How many boats are you buying?
56.
Nice. What is going to be the daily profit with this combination of 56 boats? If they're all rented out, $5,000, $40 a day. And our loan payment happens to be $35,000 a month. We went with a 15-year. You with me? So, are we going to be able to make payment? We are. Don't forget to budget for maintenance and, the parking. All right, guys, I think that's it. Are you good? Hang on, one more thing. Wait, where's the rest of the output? That's it? That's the whole output? Hang on. We gotta see the rest of the output. Where are we? Product mix? You ready? Real quick. In constraint 1, this is the amount we'd have to pay for each boat. Constraint 2 is how many boats we're buying. Constraint 3 is making sure, look at the -1. This should answer a lot of questions for you. How do you enter a negative variable? Those 2 variables that were negative, -1 and -1 is how you enter it. Okay? So we have positive, when we moved them over to the left side, they became negative. Constraint 4 is all about seating capacity, 3, 5, 2, and 6. The objective function is that profit. You ready? Are we going to get 28 and 28? Are we? All right, let's take a look. Here we go. Data, solver. Is that still E16? Is it E14 through H14? Is it, let's see, E20, E21, E22, all the way down? This is all of them? I think I don't down there anything. It's simplex. It's checked, non-negative. You ready? Is it 28 and 28? What? What happened? It took us to the other problem. Did you see that?
17.
There it is. 28 and 28. You see it? And our objective function values is the same? Is it 5,040 on the PowerPoint? All right. You guys, I'll post this also. But I'm going to post it without the solution. Please attempt to find a solution during your vacation, this one and the other one, so that you feel comfortable that you can use Power or use Excel to answer your future questions on.
So if you provide that as a question in the quiz, and you can have that output box for us again, and we just have to basically, okay.
Yeah, you're gonna see the output, you're gonna know the story. Some of them you give the story and you gotta give me the objective function constraint. Some of them you got the output, but the output's gonna be lined up to some information where I'm not saying what's X1 equal. It's gonna say, how many silver hawks are you buying? So you gotta know the variables in the story. Okay? All right, guys, I'll see you in a week, I guess, right? A week. All right.